Okay, evaluating logarithms without using a calculator. So as we get going on these, a couple things to take note of. We have the definition of logarithm or logarithmic functions going on here. What this allows us to do is switch between logarithmic form and exponential form. We're going to use that on each one of these. The other one is the one-to-one property of exponential functions. What this tells us is if we can rewrite both sides of an equation with the exact same base, and that being the only thing on either side of the equation is base raised to an exponent on both sides. What we're allowed to do is drop this common base and set the exponents equal to one another, and then solve down the resulting equation. So let's get going on these. In the top left, what we have going on is we have y equals log base 4 of 64. This starts out in logarithmic format. Let's switch it over to exponential form. So I'm going to line out my base is 4. Is going to be raised to the y power equals 64. Next, what we want to do is utilize the one-to-one property of exponential functions. So what this requires is rewriting both sides so they have the same base. What I tend to do is go with the smallest positive integer base. So between 4 and 64, I would aim to get 4 raised to a power on both sides. So in this case, we already have 4 raised to the y power on the left-hand side. We can rewrite 64 as 4 to the third power means the same thing as 64. But now we have the same base on both sides, fits into this format for the one-to-one property. So what we have to do next is drop the 4's and set the exponents equal. So we can say y equals 3. Let's go over to the right-hand side, work this problem. We have y equals log base 10 of 1,000. So the first thing to do is convert this from logarithmic to exponential form. So that'll be 10 raised to the y power equals 1,000. Okay, I would aim for the same base being 10 on both sides. We already have that on the left-hand side. We can rewrite 1,000 as 10 to the third power. With the same base on both sides, the one-to-one property says we're allowed to drop the 10's as our common base and set the exponents equal to one another. So again, y equals 3. Y is not always going to equal 3. Let's take a look at a couple more difficult ones. Same process, but a little bit different. We may have to use our exponent properties to get through this. So looking at this next one, what we have is y equals log base 121 of 11. So in exponential form, this will be 121 raised to the y power equals 11. Now, comparing these two bases, I would probably go with the smaller integer, positive integer base. So let's aim to get both of these rewritten as 11 to a power. So we already have 11 to a power on the right-hand side. On the left-hand side, we can replace the 121. That works out to be 11 times 11, or 11 squared, is equivalent to the 121. So since it was 121 raised to the y power, I replaced 121 with 11 squared, but it's still raised to the y power. Okay, next let's work on combining those exponents together because we have an exponent attached to the 11 and then y attached to the outside of the set of parentheses as a further exponent. What we're going to do is multiply these exponents to combine them together. Now it may not look like we have an exponent on the right-hand side, but that's really y or 11 raised to the first power. So if it's easier to see, you can write that 1 up in the exponent. Now we're into this format for the one-to-one property where we have 11 raised to the power on both sides. So we can drop the bases, set the exponents equal to one another, and then solve the resulting equation. So if we want to get y by itself, we'll divide both sides by 2. This will give us y equals 1/2. All right, one more on this. We have y equals log base 10 of 0.1. So in exponential form, this will be 10 raised to the y power equals 0.1. This may be a little bit easier to rewrite with the same base if instead of using a decimal on the right-hand side, if we properly read that off, it's pretty easy to see what that's going to look like as a fraction. To properly read it off, we could read that as 1/10, which as a fraction looks like 1/10. Right now, comparing these two, we'd like to get the same base on both sides. I'm probably going to go with 10, the integer value here, as our common base on both sides. So we can rewrite 1/10 as 10 to an exponent if we know our exponent properties say that we can move this 10 up to the numerator by making its exponent negative. So 10 to the negative first power is equivalent to 1/10 or 0.1. Now that we have the same base on both sides, simply drop those bases, set the exponents equal, and we solve for our variable y. Hope this helps out in solving some logarithmic equations without using a calculator. Good luck.